Alright, so 37 through 52 is basically just fill in the blank. There's no work to show. It's just knowing the different identities. So the reciprocals, these are all, these here are all reciprocal identities. And then this one's a quotient identity, the other quotient identity, the Pythagorean identities right here, and then the cofunction identities right here. Okay, so you're just filling in the blank. So no work to show on those. Okay, so I'll leave it there for a little bit longer so you guys can check and look at the answers. Alright, for 53, they gave you these two values, which you already know, right? Sine and cosine of 60. But they want you to use the identities to solve. So right here, tangent of 60, I put sine over cosine. And then simplified, the 2's cancel, so you're left with radical 3. Sine of 30, remember, sine of 30 is the same value as cosine of 60. These are cofunctions, and 30 and 90, and 30 and 60 are complementary. So cosine of 60, we know is a half, so it's a half. Cosine of 30 is equal to the sine of 60. Again, these are cofunctions, these are complementary angles. So they have the same value. Cotangent of 60 is the reciprocal of tangent of 60. So we figured tangent of 60 over here, so I take the reciprocal. And so there's the answer right there. Number 55, they gave you these two values right here. And so sine of theta is 1 over cosecant, the reciprocals of each other. So I took the reciprocal of 3 to get 1/3. Cosine of theta is the reciprocal of secant. So I flipped this number right here, and you see it right here. I rationalized it. I simplified, so 2 times 3 is 6, and then I reduced it. Tangent of theta is sine over cosine, so here's sine. Here's cosine, so I put one over the other and reduced the 3, and I had to rationalize because I was left with this answer right here, so I've got to rationalize radical 3 over radical 3, and so that becomes radical 3 over 6. Secant of 90 minus theta, the cofunction is cosecant, the angle, the complement of 90 minus theta is theta, so this equals cosecant of theta, which was given as 3. Okay. For 57, all they gave you was cotangent of alpha. This angle right here is alpha, equals 4. So tangent is a reciprocal, 1/4. For cosecant alpha, I used this identity, this Pythagorean identity right here, replacing the cotangent with 4, and then 1 plus 16 is 17, and take the square root of that. So cosecant of alpha is radical 17. Secant of alpha, I use 1 plus tangent squared alpha equals secant, oops, I forgot the alpha, secant squared alpha, and so replace tangent with 1/4, 1 plus 1/4 squared, 1/16, and you add it, you get 17 over 16. You take the square root of this to get secant, and you get radical 17 over 4. Tangent of 90 minus alpha is equal to cotangent of alpha. Again, these are cofunctions. These angles are complementary. So this equals this, which equals that, 4. So now we're down to number 59. You have to show that one side equals the other. So we only work on one side. So tangent theta, cotangent I could write as 1 over tangent, right? Because they're reciprocals. And so when you simplify that, you get that, and that is 1. So the answer is 1. So we've proven it. Alright, so what I'm going to do here is I'm going to change cosecant to 1 over sine, and tangent to sine over cosine theta. And then notice that sine and sine reduce to 1, and you're left with 1 over cosine theta, which equals secant theta. Alright, 63, we're going to use the distributive property, so it's 1 minus cosine theta plus cosine theta minus cosine squared theta. So the two middle terms cancel out, and we're left with 1 minus cosine squared theta. And remember 1, I can replace 1 with sine squared theta plus cosine squared theta, because that's what the identity is. So sine squared theta plus cosine squared theta, that's 1 right here, minus cosine squared theta. So the cosines cancel out, they're 0, and you're left with sine squared theta, which is what we have right here. Alright, so the approach I'm going to take for this one is I'm going to convert the secant to 1 over cosine. So 1 over cosine minus cosine over 1 over cosine. And then I'm going to get rid of the complex fraction by multiplying top and bottom by cosine. So cosine theta over cosine theta. So this fraction right here is equal to 1. Okay? But what it's going to do is when I distribute, it's going to get rid of the complex fraction. So here. So cosine times 1 over cosine is 1. And then minus cosine squared theta. Over, now here cosine and cosine, they cancel out, so you have a 1, right? And then 1 minus cosine squared is just like the previous problem, number 63. I can replace the 1 with sine squared theta plus cosine squared theta minus cosine squared theta. And so these two cancel out, and you're left with sine squared theta, which is what we wanted over here on this side. So for 67 through 71, we're looking for angles that make the equation true. And again, we're looking only in quadrant 1, both in degree and in radian. So for this one, theta is 30 degrees, which is pi over 6. Oops, 6. Okay, that's an equal. Right here, cosecant, remember, is 1 over sine. So that means it would be sine equals 1/2, the reciprocal of this. So sine is 1/2, again, when theta is 30. And same thing as pi over 6. So for 69a, secant is 2. That means that cosine, the reciprocal, has to be 1/2. So that would be angle 60 degrees, pi over 3. The reciprocal of cotangent is tangent, right? And the reciprocal of 1 is 1. So tangent and cotangent are both equal to 1 at theta equal 45 degrees, or pi over 4. Again, this is back to the unit circle. For a, tangent theta is radical 3. Remember, this comes from radical 3 over 1. And so this is where y would be radical 3 over 2, and x would be 1/2. So that happens when theta is 60, which is pi over 3. And then cosine is, theta is radical 2 over 2. That happens at 45 degrees, which is pi over 4. Alright, so for 85, we will have to say whether it's true or false and justify the answer. Well, we know that sine 60. Okay, so cosecant is 1 over sine. So this is 1 over sine 60. So sine 60 over sine 60 reduces to 1, and that's what we have right here, so this is true. Alright, so secant and cosecant are cofunctions, and 30 and 60 are complementary, so this is true. Alright, so we do have a property, fundamental identity, that says that sine squared theta plus cosine squared theta equals 1, but notice that in this equation, sine and cosine are not squared. So this would, I'm going to say false, but we have to prove it, right? We have to show that it's false. So sine of 45 is radical 2 over 2. And cosine of 45 is radical 2 over 2. So this becomes 1/2 plus 1. So this is 2 radical 2 over 2. When you combine them, when you add them together, the 2's reduce and to 1, and then you get radical 2. So radical 2 does not equal 1. So yeah, this is false. Alright, so we have an identity that says 1 plus cotangent squared theta equals cosecant squared theta. So I'm going to replace, just erase this. I'm going to replace the cosecant squared theta with 1 plus cotangent squared theta. Not theta, but 10 degrees. Okay, so all I did is I replaced this with this. I substituted because the identity says that those are equal to each other. So now I'm going to distribute the negative 1 here and here. So I have cotangent squared 10 minus 1 minus cotangent squared 10 degrees. So the cotangents cancel out, and we are left with negative 1. And negative 1 equals negative 1, so this is true. Alright, so this one is saying that you can reduce the 60 and the 30 degrees to get 2, right, and that they would be equal. But we know that sine 60 is radical 3 over 2, and sine 30 is 1/2, so that reduces to radical 3, okay? And radical 3 on a calculator would be, I'm just taking the approximate value, about 1.732. And if you take the calculator and you do sine of 2 degrees, you're going to get, make sure you're in degree mode, so sine of 2 is 0.0349. So these are not equal to each other, so this is false. So what this tells you is that you can't reduce the angles and get sine of 2 degrees. Alright, so the left side is saying, and I did mention it in class, that when you want to say the function squared, we don't put the square right here next to the angle, we put it in the middle, like right here. Okay, and we're going to I'm going to show you that these are not equal to each other. So tangent of 5 squared means tangent of 25. And over here, this means tangent of 5, this squared. Okay, that ratio squared. So tangent of 25 is 0.4663. And tangent of 5, and then that quantity squared, so you do tangent of 5, which is 0.0874. And it's more, but I'm just going to write that much, and then we're going to square it. That gives you 0.0, I mean, even just saying the number right now, if you square it, it's going to be a lot smaller. So 0.00765. So we could see that these two sides are not equal to each other. Okay, so not equal. So this is false.